Okay, so these properties are things you already know. Now, addition property of equality, sorry, subtraction property of equality, multiplication and division, those are just really fancy names. Okay? What it's saying is you're just adding. So, for example, x minus 7 equals 3. Well, to get x by itself, I have to add 7. That's that property. Okay, it's just a fancy name, but really it just means anytime we're adding, anytime you subtract, anytime you multiply, anytime you divide. Reflexive is, you know when you look in the mirror and you see your reflection? So it's anytime you see the same thing across the equal sign. Okay? Symmetric is when they swap. A equals B, then B equals A. It's just when they swap. Transitive is when they cut out the middleman. So if A is equal to B and B is equal to C, then you can say A is equal to C. That's the transitive property. I call it cutting out the middleman. Substitution is whenever you plug something in. And distributive, you know what that is. Okay? So take a couple minutes, like 2, and state the property for all 9. Okay, check yours with mine. Okay, so now is where the fun begins. The fun that takes place in all of this blank space on the back of your paper. Some of it. Okay. It depends how big you write. Okay, it's really not a lot of writing. So, we are starting proofs. We are starting proofs. Today and tomorrow, we're just doing algebraic proofs. These are the easy ones. Okay? So, it gets harder when we start doing geometric. So, take advantage of these fun algebraic proofs. Yes. Yes, both of them. Alright, this is how a 2-column proof works. You start with a 2-column table. Kind of looks like a T. Okay? So start with a T. And then your statements always go over here. Do you actually have to write this word? Yes. This is your statements. This is your reasoning. So you're telling me what's happening, and then you're telling me why it's happening. So if you read this conditional statement, if that, then x is equal to 7. What you're proving is that x is actually equal to 7 in this equation. So you always start off, I number all of my statements and reasonings. So like statement number 1 goes with reason number 1. And what you're always going to state first is whatever you're given. So you're going to state your hypothesis. This is just what was given to you. You know that, and the reasoning behind it is just simply that that's what was given to you. That what was what was given. Okay? So, now this is simple because you know how to solve these equations. So basically what's going to happen is you're going to solve it, but each step you take, you have to explain why. You have to give a reason. What property did you use? Okay, well, statement number 2, what's the first thing you want to do? Right, so go ahead and distribute. So we get 2x minus 6 equals 8. And so your reasoning is distributive property. You can write distributive prop. Solving the equation. Yes. So what's our next step? Okay, well what property is that? Okay, so I'm going to write addition property, and then I'm going to add 6. So 2x is equal to 14. And then 4, what property are we using? Division. Division property. So 14 divided by 2 is that your conclusion you wanted? We started with the hypothesis they gave us. Did we end with the conclusion they wanted? Okay. Now, in college, when you take college geometry, if you're going to be an engineer or whatever you're going to be, if you want to be a math teacher, an engineer, anything that has to do with math, science, you're going to have to take geometry. Okay? Now, you're going to have to write a lot of proofs in your geometry class. They're not going to be 2-column. You're actually going to have to write it out. But a fun thing that all the professors always do is they make you end your proof. So I want you to practice ending your proof. Because if I didn't put the ending of my proof on my college proofs, it would have been wrong. So I want you to practice it too. All it is 2 slanted bars at the end. It's kind of like saying, oh, I did all this hard work, and now I'm going to drop the mic. I'm done. Okay, so I want you to practice putting your ending. This means you're done. I'm done. Peace out. X is equal to 7.
So many cuts, I just write.
No, you have to write the 2 bars.
What?
Can you do what the professor's doing right or wrong if we don't do the ending?
Okay, next. That wasn't bad, was it? You just solved an equation and you told why for every step. Let's do it again. Y'all, can I tell you, I really don't even remember, like, what I did in geometry in high school. I don't remember writing proofs in high school. And then I got to college, and I wish I would have remembered because it was super hard. So take advantage of this. Okay, statements. Reasoning. Always start out with your hypothesis, what you're given. Fractions are good for you. Okay, now, from here, yours might look different than your neighbor's, and it is okay. Here's why. I like to take my n to the other side and keep my variables on this side, but somebody else might take it to this side, so it might change. Or they might subtract 7/2 first. So from here, the order doesn't really matter what step you take. When I am going to go ahead and subtract 7/2 over. So I'm going to use subtraction property. Be very careful if you're shortening the word subtraction or substitution, because if you put sub, that's either one, and I don't know which one you're talking about. So subtraction, sometimes I even come in here. Isn't 7/2 the same as 3.5?
Yes.
Okay, so I like to come in here and actually work it out sometimes so I can see what's happening. So I'm left with negative n is equal to 1/2. Y'all see where I'm going from? I'm just going back to fraction because 4 minus 3.5 is 1/2 minus 1/2 n. Okay, so 3 is going to be addition. Why? Because I need to add over 1/2 n. So now I have negative 1 plus 1/2, which is negative 1/2 n equals 1/2. Are y'all following me? What's my last step? How do I get all that junk to the other side? Divide. So it's the division property. No, that's just a coincidence. No. Well, if you're trying to prove something, then probably. Like if I'm saying prove this, then yeah. Okay, so n is equal to negative 1. Are we done? Is our conclusion correct? Mine's done. Oh, there you go. Drop the mic. I wasn't done. Okay, now we add in some geometry. It's not that bad. If y is equal to z, then prove x is equal to 100. Same thing, start with your table. I'm going to help you get started, then you're going to do it on your own. Always start with what you're given. Angle y is congruent to angle z. So 2 is given. Okay, I know they're congruent. And I'm trying to prove that x is equal to 100. So what do I do next? Set them equal to each other, so I'm plugging in, which means what property? Substitution. Good job. Was that you, Abby?
Yes.
Good. So y was x plus 10. Set it equal to 2x minus 90. Now I want you to do it on your own. Finish it out. These are kind of fun.
Are you sure?
Okay.
Yeah, I'm sure because we're playing by
Okay, now, I handed out a practice. It has 16 questions on it. I don't usually give you a lot of homework. I don't think I'm too hard on homework. But tonight, you need to finish the whole thing. The first 10 are just properties. There's only 6 proofs. Okay? So tomorrow, here is your warning. I am checking your homework.